Today, we are diving into something really out there. It's a radical new framework in physics called the fractal-causal theory. And its claims, well, they are nothing short of revolutionary. We're talking about a potential paradigm shift in how we see everything. So let's get right into it.
What if I told you that some of the biggest, most stubborn puzzles in science, things that seem totally unrelated, aren't separate problems at all? What if they're all just different symptoms of one single deep reality that we just haven't been able to see yet? That's the huge question this theory is asking.
And here's the kicker. The theory doesn't just ask the question. It claims it has a comprehensive, mathematically solid answer that connects the vastness of the cosmos right down to the cells in our own bodies. Now, that is an incredibly bold claim, so let's break down how it even begins to try and do that. Okay, so before we can really wrap our heads around a new solution, we have to understand the problems it's trying to fix. And right now, modern physics is staring down some major crises, these fundamental puzzles and inconsistencies that our current models just can't seem to solve. And the list is, well, it's pretty intimidating. You've got dark matter, right? The invisible stuff that seems to make up most of the universe. Then there's the Hubble tension, this bizarre disagreement we're seeing in measurements of cosmic expansion. You also have the mystery of why there's so much more matter than antimatter, plus the fact that our math completely breaks down inside a black hole. And it doesn't even stop at physics. The theory also takes aim at a fundamental question in biology. What exactly is aging? The Fractal-Kausale theory, or FKT for short, says it can solve all five. So how? How could one idea possibly connect all of that? Well, the FKT's answer isn't some new particle or a little tweak to an old equation. No, it's a complete reimagining of the very fabric of our reality. The heart of the entire theory is a concept it calls the bulk. The idea is that our four-dimensional universe, the one we live in, isn't all there is. It's just one layer, almost like a sheet of paper, that's being influenced by a much larger, higher-dimensional space. And in this picture, something like dark matter isn't a particle we need to hunt for. It's just the effect of a geometric pressure, like a gravitational echo from this other dimension pushing down on our own. This visual here does a pretty good job of illustrating the idea. FKT imagines the universe as this enormous, self-repeating fractal structure. Our own spacetime is just one layer in this massive cosmic stack, constantly interacting with the layers above and below it. It's a pretty wild idea that our entire reality is just one level of an infinite pattern. So that's the big picture idea. But you can't just propose something this wild without some serious math to back it up, right? A new picture of the universe needs a new equation. So let's take a look at the engine behind this whole theory. And this is it. This is the mathematical core of the theory, the proposed Einstein-Kurtzer equation. Now, it starts with Einstein's famous field equation from general relativity, but then it adds one absolutely crucial new piece, that T-bulk you see there. That's the bulk tensor. And its job is to mathematically account for all the energy and momentum that's supposedly flowing into our universe from that higher dimensional bulk. That single term is the game changer. Okay, so we have the theory, and we have the math. But an idea is just an idea without any evidence. This is where the FKT really puts its money where its mouth is, resting its case on two main pillars of proof, some incredibly powerful computer simulations and a proposed experiment that we could actually test in a lab. Let's start with the simulations. The proponents of FKT essentially built a universe inside a computer based on their new equation. The whole point was to see if the universe that this new math describes looks anything like the one we actually live in. And according to the source material, the results were extraordinary. They used these very complex statistical models, a method called MCMC, and they claim that their model perfectly reproduced the key features of our cosmos. In fact, they state that it does so more precisely than the standard model of cosmology. That's a huge claim. And here's maybe the biggest result they point to. This number. This is the value their simulations calculated for the Hubble constant, the speed at which our universe is expanding. The theory's authors say this number lands right in the sweet spot and completely resolves the famous Hubble tension, arguing that once you account for the extra energy from the bulk, the conflicting measurements finally make sense. But computer models are one thing. You really need a physical, real-world test. And they've proposed one. It's called the flerovium hypothesis. The theory actually predicts that the super heavy element flerovium would behave like a tiny quantum sensor. Its radioactive half-life should literally change in tiny, measurable ways if the local gravitational field changes. If that's true, we could actually see the bulk's influence right here on Earth. So for a minute, let's just say this theory is correct. What would that actually mean for us? Well, according to its proponents, the implications would go way beyond cosmology. It could be the foundation for some truly revolutionary, almost unbelievable technologies.
And maybe the most startling of all is something they call medbeds. The theory suggests that aging and disease are basically a loss of information in our cells, something it calls causal noise. These medbeds would supposedly work by applying a precise bulk dose of energy to restore what it calls the causal coherence of our tissue, essentially allowing for perfect regeneration and maybe even reversing aging itself.
So how on earth could you build something like that? Well, the key would be a whole new class of materials they call gradient memory alloys, or GMAs. The idea is that these materials could be engineered to directly interact with and even manipulate the curvature of space-time itself. And that would be the key to building things like medbeds, or maybe even advanced propulsion drives. And the implications could get even more profound. The theory suggests we could see whole new fields of science pop up, like causal forensics. This would be a discipline that tries to trace chains of events, not just in our world, but all the way back to their true origins within the bulk. It could completely change how we think about cause and effect. All right, so that's the theory, the math, the simulations, and the mind-bending tech. But let's bring it back to reality. Where does this whole idea actually stand today? Is it just a wild thought experiment, or is it something more? So, what's the status of the fractal causal theory right now? Well, it exists as a completed manuscript, version 4.3. Now, to be perfectly clear, it has not yet been published in a peer-reviewed scientific journal, which is a crucial step for any new theory. However, it has reportedly attracted serious interest from a commercial publisher, Noven Verlag, for a book deal. They even released a quote saying they were sustainably convinced by both the linguistic elaboration and the depth of content. So from solving the biggest puzzles in physics to proposing technologies that feel like they're pulled straight from science fiction, the fractal causal theory is, you have to admit, incredibly ambitious. It suggests we can make a leap from a science that just observes causality to one that could actually control it. Whether it can make the jump from a manuscript to mainstream science, well, that's a question we'll all be watching.